This question is from GATE 2013 Mechanical Engineering paper, question number 19. Consider one-dimensional steady-state heat conduction along x-axis, where x is from 0 to L, through a plane wall with the boundary surfaces x equal to 0 and x equal to L, maintained at temperatures of 0 degrees Celsius and 100 degrees Celsius. Heat is generated uniformly throughout the wall. Choose the correct statement. Option A, the direction of heat transfer will be from the surface at 100 degrees Celsius to the surface at 0 degrees Celsius. Option B, the maximum temperature inside the wall must be greater than 100 degrees Celsius. Option C, the temperature distribution is linear within the wall. Option D, the temperature distribution is symmetric about the midplane of the wall. So, before starting the solution itself, we can eliminate two options. One of the options is temperature distribution is symmetric about the midplane of the wall. So as temperatures at both the walls are different, at x equal to 0 it is 0 degrees Celsius and at x equal to L it is 100 degrees Celsius. So there is no way the temperature distribution can be symmetric, and therefore option D can already be marked as wrong. But we need to identify the correct statement and not the wrong one. So among these three, we'll see which one's correct. So we'll start by using the one-dimensional steady-state conduction heat equation, which is dou square T by dou x square plus Q dot upon K is equal to 0, where Q dot is the heat transfer rate and K is the thermal conductivity. And this is only along one dimension, that is x, because this is a one-dimensional problem. Let's integrate it to find out T in terms of x. Q dot is the heat generated per unit volume. Integrating this equation, we get is equal to minus Q dot x by K plus constant of integration C1. Now again integrating this to get T, we have integration of this is T is equal to minus Q dot x square by 2K plus C1x plus C2. So we see that T is a function of x. The relationship that we get is parabolic, it's not linear. So clearly temperature distribution along the wall is not linear. Option C is also wrong, which is linear distribution of temperature along the wall. Second and third term have the chances of being 0, but first term can never be 0, and therefore T is a function of x square and not linearly proportional to x. Now let's put in the boundary conditions and find C1 and C2. So at x equal to 0, T is 0. So we can write 0 equal to 0 plus C1 into 0 plus C2. So this gives us C2 is equal to 0. Also at x equal to L, T is 100. So it is 100 degrees Celsius is equal to minus Q dot L square upon 2K plus C1 into L. C2 is already 0. So from here we can find C1 as 1 upon L into 100 plus Q dot L square by 2K, which we can write as 100 by L plus Q dot L by 2K. T is minus Q dot x square by 2K plus 100x by L plus Q dot Lx by 2K. This is the expression of T. Now to find out where the maximum temperature will occur at what value of x, if we put the value of C1 here and write dou T by dou x will be equal to minus Q dot x by K plus C1 is 100 by L plus Q dot L by 2K. So from here we can get the value of x by rearranging. You will get x is equal to K upon Q dot into 100 by L plus, now when we multiply this term to the bracket, we get first term is 100K by Q dot L and second term will be L by 2. So we can see that maximum value of T will occur at a value of x which is greater than L by 2, because there is this term that is being added to L by 2. So definitely maximum temperature will occur at a value greater than L by 2. From this we can infer that heat will not flow from 100 degrees Celsius to 0 degrees Celsius, because there is a plane in between the two walls where the maximum temperature occurs, and therefore heat can flow from that maximum value of temperature to either directions. And therefore, B is also incorrect. We can also verify again that temperature distribution will not be symmetric because maximum occurs at a value greater than x equal to L by 2. So definitely there is no symmetry in the distribution, and it's not linear, that we have already established. So the only answer that is correct here is option B. Let's go back and mark it. So option B, the maximum temperature inside the wall must be greater than 100 degrees Celsius. So the maxima does not occur at x equal to L. That means that 100 degrees Celsius is not the maximum temperature. It is going to occur somewhere else, which will be a value greater than x equal to L by 2. To learn more about steady state heat conduction, you can refer to the NPTEL video. Lecture 6, 1D steady state heat conduction in plane wall with generation of thermal energy. This lecture is from the course Conduction and Convection Heat Transfer. The lecture is taught by Professor S.K. Som. He is from Department of Mechanical Engineering of IIT Kharagpur. I hope the solution will help you clear your doubt. Thank you.